Now that we've discussed static NAT, like static NAT, dynamic NAT also has one-to-one mapping between inside local and inside global, but this mapping happens dynamically. In dynamic NAT, a pool of possible inside global addresses and matching criteria is defined. Based on the matching criteria, an inside global address is assigned to an inside local address. An example of this matching criteria is inside local addresses starting with 10.1.1 will translate to inside global addresses of 200.1.1.1 through 200.1.1.5. Suppose PC1 with IP address 10.1.1.1 sends a packet to PC3 at 170.1.1.1. When the first packet from PC1 reaches the NAT router, the router looks at the matching criteria to determine whether the packet address needs translation. The matching criteria states that packets with a source IP address starting with 10.1.1 should be translated to inside global addresses of 200.1.1.1 through 200.1.1.5. Therefore, NAT chooses the first available IP address from the pool of inside global addresses and adds the translation to the NAT table. Finally, NAT translates the inside local address of 10.1.1.1 to an inside global address of 200.1.1.1. All packets that leave the router now have the source IP address of 200.1.1.1. The dynamically configured NAT table entry will remain for as long as the traffic continues to flow from PC1. We can set a timeout period for that NAT table entry. The timeout period would determine the maximum period for which there could be no traffic from a PC. When this inactivity period is exceeded, the NAT table entry is dynamically removed. To clear the NAT table entry, we can use the clear IP NAT translation command. You need to remember that we can have more inside local addresses than inside global addresses. If there is a packet from an inside local address, and all inside global addresses have already been allocated to other inside local addresses, then the NAT router discards the packet. To forward such packets, we need to keep trying until a NAT entry becomes available. Otherwise, NAT will forward packets for the next host that begins the traffic flow. Basically, the global pool of addresses should be as large as the maximum number of hosts on a network that might need concurrent access to the internet.